Hello viewers, welcome to the part 2 of the step-by-step Oracle DataGuard series, and in this part we are going to learn about the initialization parameters used for DataGuard configuration, switchover, failover, and a few DataGuard broker and SQL commands which will be used in your DataGuard configuration and administration. So viewers, in this series, I am covering various topics starting with what is Oracle DataGuard, how to implement it, switchover, failover, how to monitor and alert on DataGuard status using OEM, etc., which I am listing below. Each of the topic may need one or more tutorials to cover it completely. I assume you are already an Oracle DBA or familiar with at least the basics of Oracle database architecture. I will keep everything simple so there won't be any difficulty in understanding the concepts even if you are a beginner. So in the last part, we created a physical standby database using OEM. If you have not watched the previous part in this series, I suggest you watch that first to get a better understanding on what we are going to cover today. In the last part, the physical standby database was created using OEM, which was mostly a quick and automatic process. Most of the things like the initialization parameters, service and listener configuration, DataGuard broker, etc. have been taken care by OEM automatically, but to effectively administer a DataGuard setup, you must understand how it works. So in this part, first we will talk about the initialization parameters which are used in the DataGuard configuration. Second, we will understand the DataGuard broker configuration and how to do a switchover or failover using DataGuard broker. And third, we will learn a few useful DataGuard broker and SQL commands. Moreover, as I am using Oracle Enterprise Manager extensively in this whole series, if you want to learn more about OEM and become a master in OEM starting from installation, monitoring, alerting, upgrade, patching, etc., please watch my 16-part YouTube series named Mastering OEM, for which I have given the link in the description of this video below. Please note that whatever commands that I am going to use in this tutorial and in this whole series, they are all available in a shared document in my Google Drive. You can access that using the link in the description of this video below. Before we proceed to today's topics, let's first refresh the DataGuard architecture one more time. In the last part, I gave a very basic and high-level diagram of the DataGuard architecture to avoid making it overcomplicated and harder to understand by the beginners. But now it's time to take a little deeper look into the architecture. This diagram explains how actually the changes from the primary database are propagated to the standby. In the primary database, which is open in read-write mode, the users are connected and they are making changes. These changes generate redo data which reside on the redo log buffers in the memory. These buffers are written to the redo log files by the log writer or LGRW process, and when the redo log files are filled up, they are archived by the archiver or ARCH process as archived log files. When you are configuring your DataGuard environment with real-time apply, that means applying the changes happening in the primary immediately to the standby, then there is another process called LNS or log network service, who also reads the redo log buffers and sends the redo data to the RFS or remote file server process in the standby using Oracle Net Services. This activity of sending redo data can be synchronous or asynchronous, meaning if the LNS process at the primary waits for an acknowledgement for the redo data being received and applied at the standby end, then it is called synchronous or sync. But if the same acknowledgement is not awaited at the primary end, it is called asynchronous or async. Synchronous mode of transfer results higher level of data protection but consumes higher network bandwidth and may compromise the primary database's performance. Whereas the asynchronous mode of transfer results in better performance, consume less network bandwidth, but provides a little lower level of data protection than the synchronous mode. But whatever may be the mode, once RFS receives the redo data, it will be written over to the standby redo logs or SRLs. The MRP or managed recovery process in the standby database then reads the SRLs and apply the redo data to the standby database, which is either in mount mode or open in a read-only mode. Once the SRLs are filled up, the archiver process in the standby archives them. But in a gap resolution scenario, when due to a network or some other issues, the real-time apply fails and there is a gap between the primary and the standby DB, meaning they are not in sync anymore, then once the underlying issue that has caused the gap is fixed, the RFS process in the standby database and the archiver process in the primary communicates directly with each other to find out what is the gap, which archive logs the standby needs to recover or make the standby DB again in sync with the primary. The archive logs are then shipped to the standby database's archive log location. These are then applied by the MRP process, which is no more a real-time apply, but we can say it's an archive log apply. Once all the pending changes have been applied and the gap is resolved in the standby, the real-time apply resumes. For this kind of automatic gap resolution, two initialization parameters called Failover and Failclient are needed. We will talk about them shortly when we will discuss about the initialization parameters. So first, let's talk about the initialization parameters that are related and important for your DataGuard configuration. I am in the primary server as Oracle user, who is the owner of the Oracle database and installations. So let me first set up the environment for our DataGuard test database that is named as testdg. Now I will connect as sysuser and I list out all the initialization parameters using this SQL command, and I'll explain them one by one. So the first one, archive lag target. This determines the amount of seconds the archiver process will wait before archiving a log sequence. 0 means it is unset. If you set it, the archiver process will not wait for the log file to be filled up for archiving to make sure you don't lose data beyond an acceptable time limit in case of a disaster. Second one, DB block checking. It should be set to full or at least medium, that is MED, and this is important for detecting and resolving block corruptions. The third one, DB create file dest. The location pointed by this particular parameter determines the default location for data files. DB file name convert. If you are not using OMF or Oracle managed files, this setting determines the conversion required in the file name. For example, say your primary database files are in the file system named U001 and in the standby it is U002. Then in this parameter, you will set values U001 and U002 in the standby database initialization parameter files, and in the primary, you have to put it in the opposite order, that is U002 and U001. As in our test case, we are using Oracle managed files and our file systems are similar in the primary and standby, so we don't have to worry about setting this parameter. Then DB flashback retention target. In a DataGuard configuration, it is important to enable flashback database for quick and smooth recovery and failback, etc. This parameter is in minutes and a value 1440 means it's for the whole day or 1 day. I suggest you set it for minimum 2 days, that is 2880. Then DB lost write protect. It should be set to typical in the standby and it is important for detecting lost writes in the IO subsystem. Then DB unique name. As I explained in the previous part, in a DataGuard configuration, this parameter uniquely identifies a database because all the databases in the DataGuard configuration will have the same database name, but they will differ by this unique name. For example, if your database name is testdg and you have one primary and say 2 standby databases, then you can put the unique names like for the primary testdg1, for the first standby it will be testdg2, and for the second standby it will be testdg3. Then DB writer process. This is a performance parameter. If you have more CPUs in your server, you may consider increasing the value to 2 or something more. Then the DG broker config file 1 and 2. These two parameters define the location of the DataGuard broker configuration file and taken automatically. You may change it if you want, but by default, they will take the db create file dest location to create the broker configuration files. You see that the files are created with .dat extension. Then DG broker start. It should be set to true if you want to work with DataGuard broker. This parameter defines whether the DG broker process will be auto started or not. Then fail client and fail server. These two parameters are used for log gap resolution. Fail means fetch archive log, and the client is nothing but the standby database, and the server is the primary database who sends the archive logs to the standby. Right now, there is nothing set in these two parameters. We will learn about these two parameters as we go. Then log archive config. This parameter defines the unique name of the databases participating in the DataGuard configuration. For example, if you see, we have two database unique names mentioned there, that is testdg1 and testdg2, because our primary database has a unique name of testdg1 and this is our only standby database. If you have more standby databases, you have to put the unique names of those standby databases accordingly here in a comma separated list after the primary database. Then log archive dest1. This parameter defines the archive log location in the primary database. In fact, it's always set even if there is no DataGuard configuration related, but this is an important parameter in the DataGuard configuration also. And if you see, the location it specifies is the recovery file dest of the primary database itself. And we'll learn about the other options mentioned here, such as valid for, as we go. Then log archive dest2. This parameter defines the alternative archive log location of the primary or a remote location of the standby database. For example, if you have two standbys, you can set the dest2 and dest3 parameters accordingly in the primary. Next, log archive dest state1 and state2. These two parameters are actually related to the previous two dest1 and dest2 parameters, and they determine whether these two parameters will be enabled or not. They can accept values like enable, disable, defer, etc. Then log file name convert. This is similar to what we discussed for the db file name convert parameter. And as we are using OMF, we don't have to set this parameter here. Then the last important parameter in this list is standby file management. This parameter determines automatic file management, such as if you add a data file in the primary, the same file will be automatically added to the standby or not. And it should be always set to auto if you want to maintain the automatic management of the data files. Next thing that we need to make sure whether the flashback database has been enabled or not. As we learned about the DB flashback retention target before, it will have no impact if you don't set the flashback database enabled. So we will first check whether the flashback database is enabled or not using this SQL statement. Select flashback on from $database and we see that the flashback is on. And if it is not set, you can simply set it by using the alter database flashback on command. So these are the parameters which are very important for your DataGuard configuration. The parameters that we discussed are the most prominent ones. In fact, there are many more parameters that can govern a DataGuard configuration, but we will not cover them in this series. These parameter settings should ideally be the same in the primary as well as in the standby, except a few instance specific differences like DB unique name, log archive dest2, etc. For example, log archive dest2 parameter in the standby will have the opposite settings than what is there in the primary, because it has to shift the logs in the opposite direction when the situation arises. And I have given the overview of the parameters here, but the details about these parameters with examples along with additional options available for each of the parameters are given in the description of this video below. But for now, this much details are enough for you to start. Next, we'll learn about DataGuard Broker. So what is a DataGuard Broker? So DataGuard Broker is a additional piece of software provided by Oracle to administer and manage your DataGuard configuration. If you have Oracle DataGuard, then it is also recommended that you enable the broker configuration, because it becomes so easier to manage and administer your DataGuard configuration using DataGuard Broker. So you don't have to additionally install anything, because if you set the parameter DZ broker start to true and these file locations are valid, then your DataGuard configuration will automatically have the DataGuard broker also enabled. All you need to do is to, let's first come out of the SQL prompt, and as our environment variables are already set, all we need to do is to invoke this command dzmzrl. So DataGuard manager command line interface. So if you put a slash, then by default it will be connected using the sys user. And if you see, it is connected to the testdg1 database, that is our primary database. This is the unique name, using sys user and with the role sysdg. There are multiple options to connect. You can also connect using the sys user and the password. Say my sys user has a password of testdg for the testdg database, and if I use that, that will also allow me to connect. And another way is, say dzmzrl without any qualifier for connection, then also it will take you to the prompt where you can again connect to the database. So I'll put connect sys as with the password testdg, and it is connected. So the difference between connecting without using a username password and with using the sys user and password is that when you do actual administrative activities like switchover, failover, etc., it is always recommended to use the actual password and username pair. If you just want to log into dzmzrl and wanted to display the configuration information, etc., then you don't have to use the username and password pair. Now the next command that we are going to do in the dzmzrl prompt or DataGuard broker prompt is show configuration. I'm just copying and pasting to avoid wasting time in typos. So show configuration will give us the basic of the DataGuard configuration, which is managed by this broker setup. So if you see that there is a name of the configuration, that is testdg1.manage.home, this was taken automatically. If you remember, when we created our standby database, we enabled the DataGuard broker configuration by selecting certain options, and there it has automatically selected this name. It is changeable. If you want, you can change this configuration name to something else of your choice. Now the protection mode, it is selecting max performance based on what we selected while creating our standby database using OEM. And the members which are displayed here are the first one, that is testdg1, that is the primary database, and it has just one standby database named testdg2, that is the physical standby database. Fast start failover disable, we will learn about this as we go. And the configuration status is success, means it is a valid configuration which is currently effective. Now the next command that we are going to learn is the detail of this configuration. If you put show configuration verbose, then it will give us some more details about this configuration. Press enter, and if you see, some of the values are the same as we saw in the previous command, but additionally we can see that the properties of this DataGuard configuration is also available, like fast start, failover thresholds, operation timeout, trace level, and all these things. And we will learn about these things as we go. As of now, this is enough to see that there are multiple properties that we can control to have our DataGuard drive the way we like. And similarly, you can use another command to take a look at the details of each of the database. For example, if you put show database verbose and you put the name, see we put the name of the primary database test dg1 and press enter, you'll see that a lot of details about this primary database is being displayed. Let's go to the top of the command output, and it says the database name, role primary, intended state, transport on, the DataGuard connect identifier, and a couple of more properties of this database. So if you see in this list of properties, some of the properties are self-explanatory, and by looking at the name, you will understand what it does. I have given a link in the description of this video that will explain each of the properties. Most of the time, the default values of these properties are good for us, and if we need to make any changes, we'll learn as we go. To modify one particular property, we have to use the command edit database, then the database name. Say we want to set the property of the primary database, that is test dg1, and the property that we want to set is, say, transport disconnected threshold. It means if the transport of the log is failing and it is disconnected with the standby, how long it will wait before it signals an error. 30 is the 30 seconds, and we want to say make it to 15 seconds. Then all we need to do is to edit database, database name, set property, then the property name, and the value will be, say, 15. Press enter, and this value has been updated. Now if we run this command again, show database verbose test dg1, we will be able to see that the transport disconnected threshold is now 15. Now let's change it back to its previous value, and we will do edit database test dg, set property transport disconnected threshold equals to 30, and it is done. Please note that you can execute these DataGuard broker commands from anywhere, meaning from the primary database server or any of the standby database server, etc. Right now I am connected to the primary server and executing the broker commands from the primary server, but if I go back to our standby server, you will be able to see the same information or the output of the same commands in the standby server also. So this is my standby server, that is Linux 2. I will set the environment test dg and dg mgrl. I'm connected, and if we do a show configuration, it will show us the same information in the standby server also. And you can also do the editing of the properties from here. You don't have to stay in the primary server to make changes in the primary database. You can do that from the standby server also. Now the most important and powerful commands in the DataGuard broker is the switchover and failover activity. But before playing with the commands, let's first understand what is the difference between switchover and failover. Let's take a look into this picture. Here your primary database is in Chicago data center, where users are connected making the changes, and those changes in the form of redo logs are shipped and applied in the standby database at Denver, keeping it in sync with the primary database. When you do a switch over to the standby database at Denver, then it will become the new primary database and users will be connected to it, and then the redo logs will start going to the opposite direction from Denver to the database at Chicago data center. So switchover is a temporary role change activity, and most of the time it is performed as a planned activity. An example of a switchover activity is when you do maintenance on the primary server under a planned downtime. Now let's take a look at the same picture in the same setup. Say your primary database at Chicago data center becomes unavailable due to a disaster, and the log shipping, user connection, everything will start failing. In such a situation, you will have no options than to abandon the primary and convert the standby database at Denver to a new primary database. So users can connect and work with the new primary database in Denver, and this is called a failover. So failover is a disaster recovery activity. An example of failover activity is when primary server has a complete hardware failure, or the primary data center is down or under fire or completely inaccessible, etc. Now that we have learned about what is switchover and what is failover, now let's see them in action. So I logged into my primary server where our primary database is present, that is Linux 1 server, and I will connect to the dgmzrl prompt using the sys user and its password. First command will see the configuration. So show configuration, and we see that the primary database is test dg1, standby is test dg2. And now to switch over to the standby database test dg2, all we need to do is to use the command switch over to test dg2. You can execute this command from even the standby server also. It doesn't matter from where you are executing. Now press enter, and it will do a series of activities, like it will bring down the primary and mount it back, and then it will bring up the standby server and open it as the new primary. As we can see that it says new primary database is now test dg2 is opening. Operation requires startup of the instance test dg on test dg1, that is this server, because that will be restarted and the database will be mounted. And it is starting the instance test dg, that is in this server. Connected, Oracle instance started, connected to test dg1, database mounted, and the switchover succeeded. Now the new primary database is test dg2. Earlier it was test dg1. Now because this database was restarted, although we see the output here from the command, this session is actually disconnected. So we have to connect it again before we can execute any commands. So connect sys/test dg. Let's do a show configuration. And we can see there's a warning, apply lag could not be determined. This will go away momentarily because the role has changed, and it may take a couple of seconds before the log shipping starts from the new primary in Linux 2 server. And in the meantime, let's go back to our other server, Linux 2, and let's do the same command here. So configuration, and here we can see that now the new primary database is test dg2, standby is test dg1, that is in this Linux 1 server. Let's execute this again. The error or the warning should go away. Yes, it's gone. Now we can say that the log shipping from test dg2 to test dg1 has started. So this is how we do a switchover activity. And if we want to take a look at the database status here, let's connect to our standby database, and let's execute this command. Select name database role open mode. We see that this is in mounted mode, which is the current standby. And if we do the same statement in the other server, that is our primary server, let's copy this statement, execute in the primary, and we see that it's the primary database in read-write mode. Now we did the switchover activity. Now let's do a failover activity. So the failover is a complete disaster recovery activity, and it means that your primary database is completely inaccessible or it's completely gone. So a failover activity cannot be performed from the current primary server because it's kind of nullifies the whole point. because when your primary server is completely inaccessible, then only you will do the failover activity. So let's assume that our current primary server, that is the Linux 2, where our primary database testdz2 is present, that is completely inaccessible. And right now, Linux 1 is our server where the standby database is in mount mode. So we have to do a failover activity from this Linux 1 server. Let's do a show configuration again. Everything is all right. So what we will do, failover to our testdz1. We are considering that testdz2, which is the current primary, is completely inaccessible. And the moment we do failover to testdz1, again it will do a couple of activities, but it is much faster than the switchover activities because it doesn't have to do a lot of things with the current primary, and it will assume that the current primary is already abandoned. It's no more accessible. So whatever it needs to do, it will be in the standby server itself, and simply it will convert the standby to the new primary database. And this is completed. Now if we do a show configuration, we see that now the details are a little different, where the testdz1 is the primary database now, and testdz2, which is the physical standby database, but it is disabled and the standby database needs to be reinstated. It means after a failover, if you see that your old primary database, which was abandoned before, has become accessible again, then you can reinstate the database as the standby database. So all you need to do is to use the command reinstate database testdz2, and it will take a couple of seconds. As you can see the output, which is self-explanatory, and you'll be able to understand what it's doing behind the scene. And the final message here says that the reinstatement of the database testdz2 succeeded. It means our DataGuard configuration is back to its original state. Let's do a show configuration. As usual, first we'll see the warning because it may take a couple of seconds to start the log shipping from testdz1 database to testdz2. Let's do a show configuration again. I just waited for a couple of seconds, and yes, now we can see that the configuration status is success. Means everything is back to its original status. So this is how we do a switchover and failover using DataGuard broker. Now let's talk about a couple of useful SQL commands to administer and manage your DataGuard configuration. Now to explain the SQL commands which are useful in your DataGuard administration, I will establish two sessions using sysuser, one to the primary database and the other to the standby database. So let's come out of our dgmgrl prompt, and I will do a SQL plus /s sysdba, and I am connected to the current primary database. And I will do the same thing to the standby database also. Go to Linux 2 server, come out of dgmgrl SQL plus /s sysdba. So this is our standby database. So the first SQL statement that I'm going to use is to find out the role and open mode of the database. So I will simply copy and paste the commands so that I can avoid wasting time in correcting typos. So select name database role open mode from $database, and it gives us the name database role physical standby, and the open mode is mounted. This is a very basic SQL statement which will be used many times when you work with your DataGuard setup. And if we do the same thing in the primary server or the database, we'll see that here the name is the same, database role is primary, open mode is read write. Now the second SQL statement that we are going to use is to find out the processes and their status which are responsible for receiving and applying the redo logs. So we'll use a command, and that command has to be run in the standby database. because that is where the log receiving and apply service is going on. So we are using the statement select process status sequence hash from v $managed standby. And we see that these are the processes associated with your DataGuard configuration. They are archiver processes, DataGuard processes, RFS, that is the remote file system processes, and MRP. This is the most important process which is applying the logs that it is receiving from the primary database. And if you see that the sequence number currently is 2, and if you go back to your primary server and do an archive log list, you'll be able to see that the current log sequence is 2 here. As we are using a real-time application, that is the redo data is getting generated in the primary database and also getting applied in the standby. So we are able to see the same number here. So current log sequence is 2 in the primary, and the same log sequence is also getting applied in the standby. Then the next statement that we are going to use is to how we can cancel the MRP process. That is, this process, if we want to stop and we want to restart the database, say, then all we need to do is to execute this command, alter database recover managed standby database cancel. Press enter and it will cancel the managed recovery process, that is MRP. And if we execute this now, we'll be able to see that the MRP process is not there in this list. Again, if we want to start it back, then we need to execute this command, alter database recover managed standby database using current log file disconnect from session. So what does it mean? It's starting the managed recovery process using the current log file, that is the redo data it is receiving from the primary, and while executing this command, once it is done, it will also disconnect from the session. It means it will give back the prompt to you immediately. So if you press enter, it will start the MRP process and we will get back our SQL prompt. Yes, database altered and we got back our SQL prompt. In this command, the part saying current log file is actually responsible for the real-time apply of redo data. If you omit that part, it will be simply an archive log apply, not in real time. You can also parallelize the MRP process by using the parallel option, and we will learn about that later on. Now, if you execute this previous command again, we'll be able to see that the MRP process is again running now. Now, the next series of commands that I'm going to use gives a lot of output, and SQL plus output is not very convenient to read. So I'm going to establish two connections to the primary and the standby database using SQL Developer. So my first session from SQL Developer is connected to the primary database, and this is the first query that I'm going to use. So we'll select this query and execute it. And we see that except the first two lines, other lines have the parameters without any settings. So we have only archive-1 and archive-2 parameter set as we discussed before. So the first parameter is the local archive destination, and the second parameter is having a destination of the standby database, that is the testdg2 at Linux 2 server. And the transmit mode, that is asynchronous, and valid type, DB unique name, applied SCN, all the other details we are able to see. Now the next SQL statement is also related, where we are using select dest ID, dest name, status, type, database mode, recovery mode, protection mode, destination, database unique name, SRL, error from archive dest status. So this SQL statement is useful to find out if any of your archive destination has an error. It may be a network error, it may be something else, because of which if the destination is not able to receive or the primary is not able to send the archive logs or redo logs to that particular destination, then you'll be able to see that in this error column. If you execute it, we'll get all the details, and we see that currently there are no errors, so it is null. So everything is working as expected. The third one is the one which is actually used for detecting if there is any gap. It means, say your archive log sequence in primary is say 10, and because of some issue your standby is not receiving the archive logs and it is falling behind. Say it is currently at 6. It means it is falling behind by 4 archive logs. That is the archive gap, and that gap will be detected by this particular SQL statement. So if we execute it, we will not be able to see anything at this moment, and the log gap is actually 0, because right now whatever logs are getting generated, those are all applied immediately in the standby server. So let's try to do this, and we'll simulate that there is a log gap. So what we will do, as we can see that currently the applying log sequence is number 2, and in the primary also the log sequence is 2. So we will do a alter system switch log file. We'll do it repeatedly so that the log sequence is advanced and it will have some time to catch up. In the meantime, we'll be able to execute that query and see if there is a gap getting created. So we'll do it very fast. 2, 3, 4, 5, 6, 7. So at least it will be now archive log at sequence 9. So we will go back to our query and we will execute this, and it should show some gap. Yeah, we can see that the gap is 7, which will be resolved momentarily. So this is very useful SQL statement that I'm sharing here. You can even use it in a real application cluster or rack database environment where your standby configuration is present. So you'll be able to find out if there is any log gap between the primary and the standby. And if we execute it again, maybe it's gone. Yes, the log gap is 1. It means it's almost resolved. Now the next 2 queries that I'm going to use is on the standby server. The first query is going to give us if there is any lag between the primary and the standby. The SQL statement that I'm going to use is the select name value time computed datum time from $DataGuard status where name like percentage lag. Let's execute and see what it gives us. So it gives like there's a transport lag and there is a apply lag. And if you see that the values are differing in just seconds, it means right now there is no significant transport or apply lag. The next query that I'm going to use is the select star from $standby event histogram where name like percentage lag and the count is greater than 0. Let's see what it gives us. And it gives us nothing. We can conclude that there is no lag between the primary and the standby in terms of applying logs. So this is all for today in this part. And in the next part, we will learn about DataGuard administration and monitoring using Oracle Enterprise Manager or OEM 13c. So viewers, please provide your feedback in the comments section of the video and hit the like button if you found it useful. That will mean a lot to me and help grow this channel.